Hi kids, Mr. Jong here. Today I'm going to be going over similarity. Specifically, how can I show that two figures are similar? In geometry, when two figures are similar, they have the same shape but different sizes. Here you can see that triangle ABC is the same triangle as DEF, but just a little bit smaller. When I compare ABC to GHI, they are noticeably different shapes and therefore not similar. But what does that exactly mean? Let's dive a little deeper into what does it mean to be the same shape but a different size. In math, when we mean same shape, I mean that corresponding angles are congruent. For example, in triangle ABC, triangle A is corresponding to angle D, meaning that they are the same angle just in different shapes or different locations. If they are congruent, then I am saying that angle A is the exact same measurement as angle D. When I say same shape but different size, I mean that the side lengths are still proportional to one another. That means that all the sides on triangle A, B, and C can be multiplied by the same scale factor to result in their corresponding sides on D, E, and F. Let's take a look at an example, shall we? In order to determine if triangle ABC is similar to triangle DEF, we need to compare if they are the same shape but different size, meaning that their corresponding angles must be congruent and the side lengths must be proportional. Now, according to this diagram, angle A corresponds to angle D. And I notice they both have the same single marking tick, meaning that they must be congruent. Angle F and angle C are both corresponding, and they too share the same number of marks to represent that they are also congruent. Now, angle B and angle E both have 2 marks, representing that they are both congruent to one another, but also not congruent to angle A, C, D, or F. So in this example, we proved that all of our angles are in fact congruent. Now let's take a look at the sides. The first thing I'm going to do is mark the corresponding sides with arrows. So I'm going to go ahead and take side DE and point an arrow to side AB because they are corresponding to one another. Side EF corresponds to side BC, and side FD corresponds to side CA. As such, in order to prove that they are in fact the same and proportional, I need to construct a ratio. And so DE to AB can be represented by the ratio 2/4. The ratio of side EF to side BC, again, can also be represented as 2/4. And finally, the ratio of side FD to side CA can also be represented with the ratio 3.5/7. Now, in order to prove that these sides are proportional, all of these ratios must be the same. So what I'm going to do is I'm going to try and simplify these ratios to see if they do in fact represent the same ratio. In order to do that, I can divide this first ratio by 4/4 to get the ratio 0.5 to 1, meaning that every 0.5 units of side DE, that equals to 1 unit of side AB. I could do the same for the second ratio to get the same unit rate of 0.5 units of EF to every 1 unit of BC. Last but not least, I could do the same for our final ratio, which this time I'm dividing by 7 for both numerator and denominator. This will yield the ratio 0.5/1, meaning again that side FD, every 0.5 units of it will equate to 1 unit of side CA. Now, if we take a look at all of our ratios, they all in fact equal the same ratio of 0.5 units of the smaller triangle to every 1 unit of the larger triangle, meaning we have a multiplier or a scale factor of 0.5. And because all of our corresponding angles are congruent and all of our side lengths are proportional, I can prove that these two triangles are in fact similar. I hope that helps, kids. Until next time.